On the night of April 9th, 1945, nearly 600 Lancasters, backed by a handful of mosquitoes, converged over the German coast and swept toward Kiel, their loads aimed at the harbor and shipyards. Most carried conventional bombs for area destruction. But among them were specially tasked aircraft carrying 12,000-pound Tallboy earthquake bombs, weapons built to drive deep and break reinforced targets. This collision of extreme ordnance and a heavily armored high-riding vessel triggered an unstoppable sequence of mechanical failures. The Admiral Scheer was moored at the Deutsche Werke shipyard in Kiel. At this late stage of the conflict, the vessel lay alongside for repairs inside a shallow harbor basin, boxed in by the quay and the limits of the water itself. There would be no evasive movement, for no room to maneuver, only an immobile target of immense value. The incoming strike was not a pinpoint raid against a single tower or array. It was a heavy attack on Kiel's harbor area, shipyards, U-boat facilities, and shipping, with Admiral Scheer caught among the high-value targets inside the basin. When the air raid warning sounded across the dockyard, it triggered a rush for cover. Much of the ship's company went ashore to seek shelter. A few men stayed below to keep essential systems alive and to watch the compartments as the first blasts rolled in. Then the bombs began to hit the water and the concrete around the vessel. Tallboy was not built to scatter fragments. It was an earthquake bomb, designed to drive deep and let shock do the killing. It did not have to strike the deck. A 12,000-pound detonation beside the hull turned the harbor into a weapon, driving a crushing pressure wave through dense water and into the cruiser's submerged side. The starboard hull plating was originally designed to deflect traditional torpedo strikes and incoming naval shellfire. Under this immense area pressure, that same thick steel simply caved inward. A massive gash tore open entirely below the waterline. The sea rushed into the lower decks with unstoppable force. The Admiral Scheer possessed an extensive network of watertight bulkheads and isolation valves, but the sheer scale of the breach instantly overwhelmed the passive defenses of the starboard side. Thousands of tons of cold seawater violently entered the ship, completely altering the internal weight distribution in a matter of seconds. In water that shallow, a damaged warship might still settle with parts of its structure above the surface, but only if it goes down evenly. Admiral Scheer did not. The flooding came hard on one side. Starboard spaces filled, the weight grabbed the ship, and the hull began to roll, turning what could have been a controlled sinking into a capsize. During the raid, 5 Tallboy bombs were dropped on the ship. In a confined harbor, near misses can be as dangerous as hits. Underwater blasts and strikes on the upper works worked together to open seams on the starboard side. And once those seams opened, the fight was no longer about armor, it was about stability. To understand why that flood could turn fatal so quickly, one must look at basic stability. A warship normally stays upright because so much mass, fuel, ammunition, machinery, sits low in the hull, keeping the center of gravity down. But alongside in the fitting-out basin, Admiral Scheer's load state had changed. Much of her fuel and heavy stores were reduced or handled ashore, and only limited ballast remained to fight a sudden list. Because the fuel tanks and ammunition magazines were empty, they acted as massive, buoyant air chambers. The ship was riding extremely high in the water, fundamentally top-heavy. Its metacentric height, the critical measurement of stability that dictates how far a ship can tilt before losing the ability to snap back upright, was completely compromised. When the starboard hull ruptured from the massive hydrostatic shockwave, the asymmetrical flooding acted as a fatal lever. Water surged into those empty compartments and yanked the right side violently downward. The list came on immediately. Because there was zero counterweight deep in the belly of the ship to fight this list, the high center of gravity took over entirely. The heavy armor high up on the ship acted like a falling pendulum. The massive steel gun houses and the heavy superstructure pulled the ship past the point of no return. Sinking straight down to the harbor bottom was impossible. The vessel lost all remaining stability and rolled completely over. From the first detonations to the final capsize, only minutes elapsed. This incredibly narrow window dictated everything that followed. Damage control had no chance to correct the list and no time to counter-flood the port side back into level. Deep in the lower engineering decks, there was no safe path out once the roll began. Men inside were thrown against steel as compartments inverted, and the ship rotated exactly 180 degrees. The superstructure struck the basin floor and the ship's motion stopped, wedged in the mud of the shallow harbor. Admiral Scheer lay capsized to starboard, pinned in place by wrecked upperworks. Parts of the hull remained above the surface like a jagged island of steel against the burning night. It was not a settling, it was a capsize, and it turned the wreck into a trap for anyone still inside whatever air pockets the hull could hold. In the aftermath, some men went down with the ship and were never recovered. There were desperate attempts to find survivors in the hours that followed, but the surviving accounts are fragmentary, and the wreck's position made access dangerous and uncertain. Later reporting has put the dead in the dozens, with around a dozen still missing inside the compartments that could not be reached. By the time the dockyard fires burned down and the water went still, whatever voices remained inside the steel hull had faded. The capsize became not only a wreck in the basin, but a tomb. The immediate rescue attempt failed, and as the war ended a few weeks later, the occupying military forces inherited a 15,000-ton immovable obstacle choking the vital port. Clearing a ruined naval artery required a ruthless calculation between military necessity and industrial limits. By mid-May 1945, British forces had taken the devastated port of Kiel and inherited an absolute logistical nightmare. The harbor was a graveyard choked with twisted metal, sunken submarines, and unexploded ordnance. Blocking a critical fitting-out basin was the massive, inverted hull of the Admiral Scheer. The occupying authorities needed the dockyard operational, but moving a shattered heavy cruiser presented an overwhelming engineering barrier, an ugly trade-off between clearing the basin and the prohibitive technical cost of righting an armored citadel. The solution was a strict application of economic salvage triage. Economic salvage triage is the industrial mathematics of cost versus yield in a post-war environment. The objective is never to restore the vessel or even to fully clear the hazard. Instead, salvage teams systematically dismantle and harvest only the high-value components of the wreck. The operation continues only as long as the market value of the recovered metals exceeds the operational cost of the labor, fuel, and cutting equipment required to tear them free. The moment the extraction becomes too difficult or too expensive, the operation is immediately terminated, and the remainder of the ship is abandoned to the environment. Operating under British supervision and with records placing the first dismantling work in July 1945, industrial teams deployed onto the exposed wreck to begin a top-down stripping program. Because the ship lay capsized with sections still above the waterline, the crews could reach the massive bronze propellers at the stern without first attempting a full righting. These were highly lucrative and relatively easy to cut away for immediate smelting and reuse. Divers were also sent down into the shallow waters to torch away the heavy gunhouses and accessible surface armor plate that had smashed into the mud during the violent inversion. The recovery of these specific metals financed the early stages of the operation, but historical records from this chaotic transition period are heavily fragmented. The exact tonnage of scrap material removed by the British teams during this specific phase remains unrecorded. It stands as an unknown variable in the forensic timeline, with no surviving public documents detailing the precise yield of the harvest. What is known is exactly where the salvage operation hit its absolute breaking point. After the propellers, the accessible outer armor, and the external gunhouses were stripped away, the teams were left staring at the primary armored citadel, and this was the thickest, heaviest, and most structurally complex section of the warship. It was completely inverted and firmly entrenched in the dense harbor silt. To remove this massive steel torso, the engineers faced two brutal options: right the inverted hull with heavy pontoons and winching barges, or cut the thick armored plating apart underwater. In the decimated port, the first required specialized lifting infrastructure that simply did not exist. The second was a painfully slow and dangerous process in zero visibility, demanding massive volumes of pressurized gas, specialized arc torches, and weeks of diver time just to free a single section of high-tensile naval steel. Measured against the scrap value of the citadel, the cost of labor, fuel, gases, and cutting charges was economically ruinous. The fundamental logic of economic salvage triage dictated an immediate halt to all physical work. The heavy cruiser had been reduced to an immovable core of thick steel and dead weight. Complete scrapping was officially aborted because removing the main hull was deemed technically prohibitive and economically ruinous. With the high-value scrap removed and the profit margin exhausted, the salvage teams packed up their gear and walked away, leaving the heavy, armored torso permanently trapped in the mud, with no viable engineering solution for removal. When a massive steel obstacle cannot be dismantled and cannot be hoisted, the only remaining engineering option is to fundamentally alter the geography around it. By 1949, the ruined city of Kiel was transitioning from a state of post-war paralysis into an era of aggressive reconstruction. However, the urban landscape was entirely flattened, and the harbor was still severely crippled. In the middle of a critical fitting-out basin sat the immovable, stripped torso of the Admiral Scheer. The occupying forces and local authorities faced two distinct, massive logistical nightmares. First, they possessed a harbor basin that was completely unusable due to a 15,000-ton armored barricade. Second, they had a destroyed city that had generated millions of tons of shattered brick, concrete, and masonry. The institutional decision was made to combine these two catastrophic problems into a single, brutal engineering solution. Instead of fighting the shipwreck, they would use it. This structural concept is known as land reclamation through subsumption. In traditional harbor management, a sunken vessel is a hazard that must be extracted to restore the safe navigational depth of the waterway. In subsumption, the wreck is reclassified as a foundational volume. The hull is left where it lies, and heavy debris is poured over and around it until rubble displaces the water and the basin becomes land. The obstacle is not removed, it is absorbed into the new coastline. Executing this massive infill operation required a relentless flow of material. Fleets of transport trucks and heavy barges moved the pulverized remains of Kiel to the edge of the fitting-out basin, and day after day, thousands of tons of broken masonry and concrete were dumped straight into the water. The remaining upside-down hull sat exactly where it had rolled over 4 years prior, and the avalanche of rubble packed against its armored plating, using the wreck as a void filler and cutting the total volume of fill required. As debris crushed into harbor mud, the basin's water was forced outward, and the artificial shoreline advanced, burying the shattered starboard side and sealing the wreck beneath layers of stone, dirt, and compacted fill. Under that growing load, the warship did not collapse. The heavy naval armor took the pressure and became a subterranean spine for the reclaimed land. By the early 1950s, the fitting-out basin was gone. In its place was a broad, engineered expanse where rubble and fill had replaced water and rewritten the geography of the port. The authorities repurposed this reclaimed ground as part of the Naval Arsenal Complex, with the wreck entombed several meters below a grassed area rather than sitting beneath an active excavation site. The water was entirely replaced by pavement, and the immediate visual evidence of the catastrophic sinking was completely erased from the environment. The basin was paved over, and the heavy cruiser disappeared from the map entirely, lost beneath thousands of tons of concrete and dirt for over 7 decades. Looking beneath 7 decades of post-war fill and modern infrastructure means fighting severe sensor limits. The Marine Arsenal grounds in Kiel-Ellerbeck are a tangle of reinforced concrete, buried masonry, rails, utilities, and compacted rubble that can scatter and mask conventional signals. Ground-penetrating radar struggles in that kind of broken, conductive fill and an open excavation would be massively disruptive inside an active military-industrial zone. In the early 2020s, researchers initiated a comprehensive geophysical survey to map the subterranean footprint of the old harbor. Using reflection seismology, they sent controlled, low-frequency energy into the ground and listened for the hard boundary where compacted rubble gave way to dense naval steel. A grid of geophones recorded the returning echoes, and computers stitched those returns into a 3-dimensional subsurface model. When the Ellerbeck data were compiled, the survey traced a clear outline of the wreck beneath decades of fill and corrected older guesses about its position. Large sections of hull and superstructure still appear to survive under meters of sand and debris, even if the resolution cannot cleanly separate every component. Public reporting has described the surviving mass as close to 70%, yet the safer conclusion is simpler. Post-war scrapping removes some exposed sections, while substantial portions remain entombed where the harbor basin was filled in. The heavy cruiser was not hauled away, it was built over. The sheer mass of the buried warship, combined with the modern infrastructure built directly on top of it, means the vessel will likely never be extracted. Digging through an active industrial zone to reach thousands of tons of heavy steel would be financially crushing and physically disruptive beyond any plausible historical or salvage return. So the heavy cruiser remains what subsumption made it, a vast inverted void filler under concrete and traffic, a permanent engineering anomaly. Now the subterranean foundation of the city that built it,